Okay, question 2. Question 2A. A1. Find the period, amplitude, phase shift for the function, hence or otherwise. Sketch the graph between negative pi, less or equal to x, less or equal to pi. Now let's find the function given, f of x, is 1 minus 3 sine 2x minus pi over 2. So what's the amplitude? The modulus of negative 3, which is 3. The period, 2 pi over 2, which is pi. And the phase shift, meaning the horizontal, it will to be given by 2x minus pi over 2 is 0, which is pi over 4. So pi over 4 to the right, the vertical shift, 1. So we put a scale, which is period over 4. Okay, so we can sketch. So we have pi over 4, period, pi over 2, 3 pi over 4, pi, negative pi over 4, negative 3, negative pi over 2, negative 3 pi over 4, and negative 2, negative pi. Okay. And then the amplitude is 3 and negative 3. So first thing is that we can put the initial graph and then shift it. So this is the sine negative graph. So the original one comes this one. Because it's negative. so just put it on the right before we extend the other side. Then shift pi over 4 to the right. So every point moves to the right. This guy comes here, there, and this guy comes here. So we'll have this graph. So something is missing outside. That is if there was something else, but we are told we should end at pi. Then we lift this by 1 going up. So we put a 1, we put a negative 2, we put a 4. So this moves there, and then the other one moves to negative 2, moves to 1, and moves to 4. So we have this graph like that. So extending it on the left, this guy must go where? Must go there. Okay. And then come down further, negative 2, get back and go further. So it will follow This is now after you've done everything. You realize that your thing is getting like that. So when you graph it now, our graph becomes the graph of this one. So this is our f of x is equal to 1 minus 3 sine 2x minus pi over 2 within the required interval. So the first 1, 2, 3 graphs, the first 1, 2, you're trying to understand which points will allow it to blow. After knowing, then you can now complete your sketch. So the negative has taken it down. The shift has made it look like you're sketching course. Okay. Then we sketch another one. So we are sketching, this must be 2 then. We sketch y is equal to arc tan x. This is the same as tan inverse of x. Now remember what we agreed about the tan inverse thing. So here we said that when you are sketching the inverse, you bring the 1 and -1 on the x-axis and take the angles. Now this sketch is open and not toward the range. So where do you take the angle? So we take the angle where here, this is pi over 2, and down -pi over 2, and then that is pi, and this is -pi. Now remember, tan pi over 2 is the same as sine 90 over cos 90, but cos 90 is 0, so it's undefined there. So we put dotted lines here and there, and then sketch our graph coming from where, if it was on the x-axis, remember, you have that, tan would become like this. So it's coming from the positive, so even this guy must come from the positive. So from the positive, and it must be going down like that. So that here, it will go like that, and here, it will come like that. First it was open, it was just saying sketch. So you could pick the smallest interval, that is -pi to pi. And then you sketch a graph. So I've sketched the tan, and then we have translated into the arc tan. So this was the tan here that I was demonstrating. When you take it to the arctan, it becomes very easy. Because you're just changing whatever is on the X, you take it on the Y. That's it.
Sir,
Oh no.
how have you solved the sine 90 and cos 90 on the graph here?
We haven't solved on the graph. We are saying since tan 90 is the same as sine 90 over cos 90, but cos 90 is 0. That tells us that tan 90 is undefined. So because it's undefined, when we go to the graph, we'll put dotted lines where there is 90 because we don't know the value of tan in there. That's why they have appeared here. Just to remind us that tan is undefined at 90. Is that okay?
Sir,
Hello.
but why didn't you put these lines on in the y-axis, the y direction, on the -1 here, somewhere here? Why didn't you put them there?
When you put them there, it means that you're dealing with tan. The way they are put here is because we are dealing with tan. When you're dealing with arctan, the inverse of tan, you take them to follow the X.
Oh, okay. Thank
Yes.
you.
Yeah. Okay, so we use this space to solve the other question because it's simple, so it can fit here. So we call it 3, but it's labeled 2 here. Given that given the equation arc sine x over x minus 1 is equal to pi over 6. So for x, now pi over 6, you know that it's 30, right? And arc sine is the same as sine inverse x minus 1 is equal to pi over 6. So if I apply sine here and apply sine there, then on the left sine inverse will disappear there. I'll just remain with the inside, but sine 30 is half. So I remain solving 2x is equal to x minus 1, which is 2x minus x is minus 1. But this is just x is equal to -1. So I found the value of x that is being asked, which is the easiest thing. If you don't want to apply sine the other side, you just take back the sine inverse where it is, because you know that whenever I have sine theta is equal to half, you say theta is sine inverse half. So if I find this, I can still write it as sine theta is half, which is what we have done, because to write it like that, we apply sine both sides. Then the other side, where is the inverse disappears with the sine. B. Find the exact solutions of the following. 1. E to the power 2x minus 8ex plus 12 is 0. So you write this. You say this is ex squared minus 8.
Can we go can you go through the previous question again?
So if you have sine inverse is equal to something, it's the same as that thing inside the inverse is equal to sine the thing on the other side. I'll give you an example. If I'm told sine x is half, then it's the same as saying x is sine inverse half. On the calculators, you even say second function, then sine inverse half for you to get the value of x. So now we are given this situation. So we had to write it in this form. Okay, except that for half there, we found what sine 30 is. So it is half, and that's why things became like that. Okay, so after you write ex squared, then you let, that is if you want p to be ex, and then use p instead of ex is 0. So you say p squared, 6 times 2 can give us 12 and also can give us 8. But because 8 is negative, we'll use minus 2 and minus 6. Because we know when you multiply both of them, the negative will disappear. So we'll have p here, p minus 2, we'll have 6, p minus 2. So this is telling us that p is 2 or p is 6. But what is p? P is ex. So ex is 2 or ex is 6. If we apply the logarithm, we apply the log base e to ex, which is also, we also apply on the right that, or we apply log ex, we also apply the e to 6. In the first one, the x will come down and log e becomes 1. Then log e, remember we said we can write it as ln, or x is equal to ln 6. So these are the values of x, the exact values of x. The second one, you have log ex minus log x e is 0. Very, very easy. Find x. Now this x is in the base. So you know that the first thing to do here is to change the base from x to e, so that you have log e over log ex is 0. So you've changed the base from x to e, and then you can see that this guy here is what we have done there. So in the cross multiply, we'll have log ex squared minus 1 is 0. 1 because that is e there. So difference of two squares will give us log ex minus 1, and also
Wait, why are we crossing multiply when there's a sign there? The negative sign.
you know what we have? We have something like this. We have something like this. We have log ex minus 1 over log ex is equal to 0. If you don't use the word cross multiply, you get a common denominator, so that you have log ex squared minus 1 is 0. Then multiply throughout by log ex. You remain with log ex squared minus 1 is 0. It has gone back to cross multiplying. Then difference of two squares, we'll have log ex minus 1 and log ex plus 1 is 0. So that log ex is 1 or log ex is negative 1. Now from the first one, you raise it to exponential, it will be e power 1 is x. The second one, e power negative 1 is x. So the values of x is e, or x is 1 over e. That's what e to the power negative 1 means. And that's what e to the power 1 means. So you get these expressions. Nice ones. Isn't that nice? If you know how to change the base. If you don't know, how to change the base, when you see such a question, skip. Go and solve what you know. If it's the only question, submit your name and leave the exam. Because there's no magic that you can use. This one requires change of base. So I'm not a motivational speaker, so I won't tell you that if you find this question and you don't know what to do, things will be well. It's just it is. Okay. Next question, C. C is induction. And we thank COVID, there's no induction. So you move on. You skip C. You go to question 3. Question 3a. Evaluate each of the following limits. 1. The limit as x goes to, it cannot go to x, it can go to 2, of x3 minus 8 over x squared minus 4. Now, if you try to substitute 2 here, you get 0 over 0, which is undefined. So, use the 2 to reduce the x3 there by synthetic. If you like long division, by long division. So you get that. So the numerator becomes x minus 2. And then x squared plus 2x plus 4. The denominator, difference of 2 squares, and then this guy and that guy takes each other. Then you remain with the good guys. This, that, here, over this. Then you substitute. You have 2 squared, 2 plus 4 over 2 plus 2. And this is 4 plus 4 plus 4 over 4, which is 3. Because on top there you get 4, and then down you have the 4. So you have a 3. Second one, the limit as x goes to infinity. of 2x 3 plus 1 over 6 plus x squared minus 3x 3. So this is the same as the limit as x goes to infinity. You factor out x3 on top, you remain with that. You factor out x3 down, you remain with 6 over x3 plus 1 over x minus 3. And so that guy and this guy cancels. And then the limit, remember that the limit as x goes to infinity of 1 over x, it gives us 0. So using that principle there, we remain with 2 over negative 3 as our solution, because the other parts will go to 0. So that will be our solution. We go to B. Determine whether the function f of x is equal to x plus 2 for x less or equal to negative 1, x squared negative 1 less than x less than 1, negative x plus 1, x greater or equal to 1. After your test, which is after next week, because test 2 is after next week, physical school test. Now after that test, don't tell me that no sir, I didn't see that they were asking at, because here they're asking at 1, check continuity at x is equal to negative 1. 2, at x is equal to 1. So them not hear stories that me I only saw x is equal to negative 1. They will come like this, negative 1 and 1. Because this question is there. This question is a very nice question, and he likes it. So he may just temper with some functions here, but the graph will come out almost the same way, and the answers will be the same. So don't mess up here. Make sure that you get, because altogether this is about 7 marks. Yeah. First thing, for 1, if you want, you can sketch it. Sometimes you can say sketch and find the limit. So if you're sketching it, you say, okay, I want to sketch it first. So here, because we are discussing, we'll sketch it. We are starting at negative 1, going to the left. But when we have negative 1, we'll substitute in the first function, because it is included in the first function domain, x is less or equal to. But when y is 0, x will be negative 2. So this is just a straight line passing through negative 2. So we are done with the top function on the sketch part. The middle one, we substitute negative 1 in x squared so that we get negative 1 squared, which is 1. We don't include it. So we are going to open, but we have found that the first function has closed. So we won't do anything there. We just check what happens at 0. When x is 0, you get 0. When x is 1, you have f of 1, which is 1 squared, which is 1. It's not included. So you open there and then you sketch. Now some people are very fun. You don't know what to do. You don't know. you don't know how to treat the negative 1, 1 when you are doing with the second function. So you know it is closed by the first function, and you know it is open by the second function, but you don't know how to write both of them. Then you come and do this, and then sketch like that. Here, you don't know what you are doing. So you want the marker to guess. Now, the guesswork that we do here is to guess that you don't know and give you 0 for the graph. Because you don't know. Because if you knew, you would have left it like that on that part. Then when x is 1, again the third function, when x is 1, you have negative 1 plus 1, which is 0. So you go at 0 and include it. Because it's included, then you pick a number, say 2, and check where it is going. So f of 2 is negative 2 plus 1, which is negative 1. So it's going down. You sketch it this way. So the sketch is complete. Now you check for continuity. So continuity at x is equal to negative 1. First, you check f of negative 1. F of negative 1 is equal to, we have found it here. It is equal to 1. So it is defined. Remember, I need to check for the limit. Now the limit as x goes to negative 1 from left. From left, it will use this line from left. That's the line that is coming from left of negative 1. So use that line, which is that function, which is negative 1 plus 2, which is 1. You also have the limit as x goes to negative 1 from right. Now from right, you are using this curve, because that's the one that has the right side of that one there, and that is x squared, which is negative 1 squared, which is 1. Now because the two side limits are the same, you are saying the limit as x goes to negative 1 of f of x exists, and it is equal to 1. Then the third thing is comparing now this limit that I have here of f of x, which is equal to 1, is it the same as f of negative 1? They're the same because they are both 1s. Therefore, you say f of x is continuous at x is equal to negative 1. You are done with 1. 2, you check what is f of 1. F of 1, you go where 1 is included in the last piece and use that. So you get negative 1 plus 1, which is 0. That was the first piece of that. The second piece of that, you look for the limit as x goes to 1 from left. Now from left, we are using this curve. It's the one that goes to 1 from left. And that curve there uses this, which is 1 squared, which is 1. You also check, so this was from left. You also check as x goes to 1 from right. From right, this is the one that has the right side of 1. And that is negative x plus 1, which is equal to 1 minus 1 plus 1, which is 0. Now, because the limit as x goes to 1 from left of f of x is not equal to the limit as x goes to 1 from right of f of x, then the limit as x goes to 1 of f of x does not exist. Hence, f of x is not continuous at x is equal to 1. Fully answered. This kind of a question came. This kind of a question will come, and this kind of a question is coming in the test. Test 2. So don't mess up. You should get it. It's an easy question. Then differentiate the function f of x using first principle. C, f of x is equal to the square root of the square root of x plus 1 from first principle. To get the derivative from first principle, you say the limit as h goes to 0 of f of x plus h minus f of x over h, which is the limit as h goes to 0. F of x plus h, this is x plus h plus 1 minus x plus 1 over h. Then you rationalize the numerator so that you extract the h. So you multiply the top part by x plus h plus 1 plus x plus 1 and divide by the same x plus h plus 1 plus x plus 1, which is the limit as h goes to 0. The numerator, when you multiply this part by that part, you get x plus h plus 1. And when you cross multiply this part in that part, in this part, in this part, you get 0. And then the other part, you get minus x. When you expand, you get minus 1 over h. Then the other part is fixed. X plus h plus 1 plus x plus 1. And then that goes, 1 goes. So we remain with it. We remain with only h in the numerator there. And then that h cancels this h here 1, this h there 1. So we have remained with the limit as h goes to 0, 1 over the square root of x plus h plus 1 plus x plus 1. Then you substitute where there's h, you take 0. You have 1 over x plus 1 plus x plus 1. This is 1 over 2 x plus 1. You can add them because they are the same. And that's how you get the limit there. Is that okay?
So, sir, can we end there, or if we want, we can rationalize the denominator?
Even if you rationalize, it won't give you any marks for rationalizing. The idea is when you're differentiating, you don't need too much simplification.
Okay, thank you.
Okay, we got question 4. Question 4a. Differentiate each of the following. 1. Y is equal to e 2x multiplied by x squared plus 1. This is an exponential. So for an exponential, when you're differentiating e, you let u to be the power of
So
e.
isn't the 2x negative?
It's positive. Yeah, it's positive. Okay. Then you differentiate, so you get u prime. So differentiating a u, you use product rule where you differentiate this 2x first. Its derivative is 2, and then you multiply by x squared plus 1. Then you add, you maintain the 2x and differentiate this. Now that the square root of x squared plus 1 is the same as x squared plus 1 to the power half. So differentiating it, you drop the half. From there, you subtract the 1 from the half, you get negative half, and then you multiply by the derivative of x squared plus 1, which is 2x. That is why we say use chain rule. Then you have 2 root of x squared plus 1 plus this 2 and that 2
Sir,
cancels. Hello?
what are we finding on this question?
We are finding the derivative of y.
Oh,
Yes. That's too far. So x times 2x, we get 2x squared, and then we can say over the square root of x squared plus 1. Over because that half is
sorry, sir.
negative.
Just
So how did you get rid of the e,
and repeat
the
what was
exponent?
We haven't gotten rid of the e. The e is there.
Oh, we are first solving for the power.
So we are saying when differentiating e, you get its power and let it to be u. Then differentiate your u because the derivative of y with respect to x is going to be u prime e to the power u. Now that u prime has been found to be this, then we are saying 2 root x squared plus 1 plus 2x squared over the root of x squared plus 1, this multiplied by e 2x, the root of x squared plus 1 is the derivative of y. This is the answer we are looking for. That's how we differentiate. Now, yesterday, is it yesterday? It's on Wednesday. I sent a video on the derivatives of trig and the logs and exponentials. So those who watched, this is now a revision. But my students, they have not watched. So kindly watch so that this becomes a revision. Now that you have started with this, when you watch it with the revision, so you'll be able to understand how to use chain rule. So here I'll just use product rule first, except that in differentiating the x squared plus 1 to the half, we've used the chain rule. That's all. So it's very, 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 very easy. So we differentiate the second one, the y, which is ln x squared plus 1 over tan x. So here we use quotient rule, where we let u to be ln x squared plus 1 and let v to be tan x. To differentiate u, you differentiate what is inside ln. What is inside ln is x squared plus 1. So you differentiate it, you get 2x. And then divide by the whole thing inside ln. Every time you find ln and they are differentiating, that's what you do. You differentiate what is inside ln and then divide by the whole thing which is inside ln. So in the video there, you'll be able to see that if you find log to the power something which is not ln, which is not e, you first change the bases to e so that you have ln, and then that's when you differentiate. So you'll see that there. Then you differentiate v. Derivative of tan, remember derivative of tan, we said it is sec squared x. So you don't have to forget derivative of tan. We derived this. Together, we derived, and I also derived in the tutorial video. So now dy dx, which is the derivative of what we are looking for, is u prime v minus v prime u over v squared. But u prime is 2x over x squared plus 1. And v is tan x minus v prime is sec squared x. U is ln x squared plus 1 divided by v squared, which is tan squared. That is what we are looking for as a derivative. So everything is okay. Everything is fine. B. Given the curve x3 plus y squared minus 4x plus 2y plus 3 is equal to 0. We do what? Find the equation of the tangent line to the curve at the point 2, 1. Now, when you're dealing with a curve, when you're looking for the tangent line, line means y is equal to mx plus c. Okay? Tangent gives us the idea of how to get the m. Now, the m is the derivative of this thing evaluated at that point. So we differentiate this thing, we get dy dx. But to get dy dx, we must use implicit differentiation because of what we have as a curve. So we differentiate our curve, we'll get 3x squared. The derivative of y with respect to itself will be 2y, but because y is a function of x, dy dx minus 4 plus the derivative of 2y is 2. Because we have differentiated y, we get dy dx is equal to 0. So we factor out dy dx and remain with 2y plus 2. And take 4 the other side and 3x squared. And then divide 2y plus 2, divide 2y plus 2. So we have dy dx is equal to 4 minus 3x squared over 2y plus 2. Now m is equal to dy dx evaluated at 2, 1, which is 4 minus 3. Where there's x, you take 2 over 2. Where there's x, where there's y, you take 1 plus 2. And this is going to be 4 minus 6 over
So the x is squared.
4.
So the 2 should be squared.
Okay, 2 should be squared. Thank you. So this is going to be 4 by 3, 12 over 4. So that we get negative 8 over 4, which is negative 2. So negative 2 is our gradient, is our tangent line gradient. Now, because it's a tangent line, we fix that gradient. So we are saying y is equal to negative 2x plus c. But what is c? We use the very point. That is x, this is y. So where is y, we take 1, and where is x, we take 2 plus c, implying that c is equal to 1 plus 4, which is 5. And so y is equal to negative 2x plus 5. Done. This is the tangent line equation. If we are asked to find the normal line, the difference would have been the gradient. This is where we say the gradient of the tangent multiplied by the gradient of the normal, we get negative 1. So here I would have said 2 multiplied by the gradient of the normal is negative 1, which is the gradient of the normal is negative 1 over, over negative 2, which would have been half. If we were asked to find the equation of the normal, now we've been asked to find the equation of the tangent. So, yeah, we are done on this part. Next question. C. Find the stationary points for a function f of x is equal to x plus 9 over x. F of x is equal to x plus 9 over x. Find the stationary points for this function and determine their nature. Stationary points are critical points. Critical points are obtained by getting the derivative and then equating it to 0. Get the values of x, substitute in f, then you form points. So the derivative of f, in this case, f can be written as x plus 9x negative 1. So to differentiate f, we'll get 1, the derivative of x, minus, we drop the power, we'll get 9, x negative 2. This can be written as 1 minus 9 over x squared. Then we equate it to 0. So we'll have 1 minus 9 over x squared is equal to 0, which implies that 1 is equal to 9 over x squared. Cross multiply x squared is 9, implying that x is plus or minus 3. So you get negative 3, take it to to f, and get negative 3 plus 9 over negative 3, which is negative 3 minus 3, which is negative 6. So we have a point, negative 3, comma negative 6. Another point, we get f, take positive 3. So we'll have 3 plus 9 over 3, which is 3 plus 3, which is 6. So we have another point, 3, 6. Now, these are the 2 points that we have. We need to know their nature. To know their nature, meaning we need to know whether they are maximum or minimum turning points. You can decide to check whether the function is increasing or decreasing so that you get the nature, because if it was increasing before that point, then that point is maximum. If it was decreasing before that point, then that point is minimum. Or you get the second derivative. Differentiate your answer. Differentiate this. You will get positive 18 x to the power negative 3. Then substitute now. In this, substitute negative 3, the x value. So you get 18 negative 3 to the power negative 3. This means that you're dealing with 18 over negative 3 to the power 3, which is 18 over negative 27. 9 in 18, 2. 9 in 27, 3. Now what you have gotten is less than 0. If the second derivative is less than 0, it means that the point negative 3, negative 6 is the maximum point. Okay, and so we use a relative maximum. So we're saying is the relative maximum point. Okay, in the same second derivative, you take 3, you get 18, 3 to the power negative 3. This is 18 over 3 to the power 3, which is 18 over 27, which is 2 over 3, greater than 0, implying that 3, 6 is the relative minimum point. So you have obtained the points and you have stated their nature. And that's what we do. Isn't that nice? So that one's done. Then you go to the second one. So this was 1, C1. You go to C2. The concentration of hydrogen ion in a solution is given by C is equal to H squared plus 10 to the power negative 4, everything over H. For what value of H is the concentration a minimum? So you are doing the same thing, find the minimum value. So we can write this as H. Do we need to write it? No, let's just keep it like that. Let's find the derivative of C. The derivative of C is going to be, we use quotient rule, where we differentiate the numerator, we get 2H, and multiply by the denominator, H. Remember, I'm saying let U be the numerator, H squared plus 10 negative 4, and the V be the denominator, H. The derivative of U is 2H. The derivative of V is 1. Remember, the 10 to the power negative 4, that's a constant there. So don't drop the negative 4 and start differentiating it. It's a constant. The derivative of a constant is 0. So you have U prime multiplied by V minus V prime, which is 1, multiplied by U. So we'll have this over H squared. Then we equate this to 0. So we have 2H squared minus H squared minus 10 negative 4 over h squared is equal to 0. Cross multiply the h goes. Then you made it 2h squared minus h squared. You have h squared minus 10 to the power negative 4 is equal to 0. Take this the other side. You have h squared is equal to 1 over 10 to the power 4. Square root. You get h is equal to plus or minus 1 over 10 squared, which is plus or minus 1 over 100 as your h. Now you are looking for the minimum h. So which h between these two is minimum? So which h is minimum? So you say, okay, the minimum h is, I will differentiate my derivative again, the c prime. Or in other words, I can first divide the c prime as, since we have gotten h squared, was this 2 when we multiply, it was giving us 2h squared minus h squared minus 10 negative 4 over h squared. This is the same as h squared minus 10 negative 4 over h squared. So I can write it as h squared over h squared minus 10 negative 4 over h squared, which is the same as 1 minus 10 negative 4 h negative 2. So this is my c prime. So I can differentiate it again to get the derivative of 1 with respect to h is 0. The derivative of h negative 2. Okay, hope we're ending soon. This is the last question. So the derivative of h negative 2 is giving us 2 10 negative 4 h negative 3, which is 2 10 negative 4 over h to the power 3. So this means that when you bring in c, when you bring a positive number 100, you will get a positive number because of the h3 here. When we bring a negative number, you will get a negative number. Now we want to find where h is what? Where h is minimum. So we want the positive one. So we are saying the h that gives minimum is h is equal to 1 over 100. This is the value of h that we are looking for, the one that gives us the minimum value of the concentration. And this is where the class for today ends. So we have finished the whole test 2 for 2018. So you can have a good day. Today they have given us a Black Friday, no cutting us on Zoom. That's a good thing.